Assalamu alaikum warahmatullahi wabarakatuh. In today's lesson, we are going to work on continuously the refractive index. So you know that one refractive index is the refracting power. You got the details. Refracting index is more than 1 mean the light will be refracted towards the normal. If the refractive index is less than 1 mean, it will be refracted away from the normal, and it decides the how much the light ray is bending. In this lesson, we are going to determine the refractive index. We are going to give certain more ideas regarding refractive index. The very first thing, refractive index is represented using a large size capital N, simple A, okay, a large size simple N, say this way, say this way, a large size simple N is used to represent the refractive index. Okay, so this is the symbol of refractive index. Okay, so if you want to write refractive index of glass with respect to air, okay, refractive index of glass with respect to air. What is the meaning? Incident ray in air and refracted ray in glass. Okay, that is the meaning. Refractive index of glass with respect to air mean first light is traveling through the air, then it is refracting into the glass. How to show this one in symbol? We can take this N, okay. In the front you have to mark A in small size with respect to air. No? On this side you have to mark a simple G like this. So that is representing refractive index of glass with respect to air. So with respect to whom is written in the front. Whose refractive index written on the hind side? If so, you can plan to write, okay, these refractive indexes. Refractive index of water with respect to air. Refractive index of diamond with respect to air. Refractive index of glass with respect to water. Refractive index of diamond with respect to water. refractive index of perspex with respect to air. Refractive index of water with respect to diameter. It's not a matter. You just write each for these a symbol. Each for these a symbol. Like that I have worked. For each of them, you work a symbol. Okay. Now, I am going to tell you an important thing, that is how to calculate, calculation of refractive index. Calculation of refractive index. In the calculation of refractive index, there are three methods applied. One, we say ratio of velocities of light in the two considered media. Ratio of velocities of light in the two considered media. Second method, we apply Snell's law to come to this idea behind refractive index. And third, it is apparent depth, real depth concept. Okay. Whatever the way you apply to calculate this refractive index, it will give you the same answer. The only thing it is, the measurements you are taking are different. In the first case, you are considering the velocities. In the second case, you are considering the angle of incidence and angle of refraction. In the third case, you are considering the depth, okay, that is measured in meters. So in this lesson, I am going to tell you the concept one by one. Okay, so our heading is going to be calculation of refractive index using velocities of light in two considered media. Calculation of velocities of light in two considered media. In that case, if you want to work out ANG, if you want to work out ANG, okay, that is refractive index of glass with respect to air, right? If you want to work out it, you have to write a ratio. The ratio I will write first. I will write the velocity of light in air down. I will write velocity of light in glass. Velocity of light in